Hello, this is Chris Marlowe. I'm a solutions engineer here at Pfannenberg, and today I'm going to be teaching you how to get and how to use the Pfannenberg sizing software, also known as the PSS. To start off, you're going to want to go to pfannenbergusa.com. Once there, go to the Resources tab and click on Sizing Software. That'll bring you to this web page here, and all you have to do is scroll down to the bottom and fill this form out here. Once you've done that, it'll actually take you to the sizing software. Once you're here, I recommend bookmarking this page. That way you don't have to fill the form out again, and you can always just come straight here. So before we start the project, you can actually go to Preferences here under Project, and you can change your units that you'd like to use, as well as the language. We're going to start a new project. To begin any project, you do have to have a project name. I'm going to be using Scenario for my project names today. So once you have a project name, you can click on the Enclosure tab. From here, you will have to fill out all the information on this page, besides type. So for our first scenario, we have a 48 by 36 by 18 enclosure. Our standard temperature for the switch cabinet is left at 77 to 95 degrees Fahrenheit. That is the standards that we recommend using for enclosures based on condensation and average components going inside of them. Here you can also select the type of housing material you have. We have a pre-selected list that has the K values filled out, but if your material isn't on this list, you can also manually input the K value for that material. You can also select the voltage that you have available inside your cabinet that help better select a unit for you at the end. From here, you're going to either click Continue or click the Environment tab. And here you can select the NEMA type that you need. So if it's going indoor, it's going outdoor, and it's going to a washdown environment. For outdoor and washdown, you can also supply a solar load. That's if it's going outside and there's not going to be any shade, so there will be heat radiated from the sun that the enclosure is going to absorb. You can also select wind when it's outdoor or NEMA 4X, and that will help with thermal calculations as well. For this one, it's going to be an indoor, so NEMA type X, 12, sorry. And then here you can select the type of housing it is. Freestanding with all sides exposed, wall mount, middle, basically all the formations you can have for standings. And this actually helps with the thermal because the more sides that are exposed, the more heat can be transferred from the environment to the ambient and vice versa. I'm not going to change my ambient right now, and I'll come back to this. I just want to show you something when you're trying to use a filter fan when your ambient is the same as your enclosure temperatures. So on the Dissipations tab, you can actually enter if you already know your dissipation, or you can use two different forms of calculation. One form is if you have recorded a temperature that your enclosure has reached with all your components running, and then an ambient temperature that you've also recorded. And this way it will back calculate the heat load inside your enclosure. For these scenarios, we're going to be using the components selection. So you can select your components and it will calculate your heat load. So when using components, I recommend always having any drives, any transformers, any power supplies, because those are your three main heat load components inside of an enclosure. This one has a 4,000 watt power supply. A 3,000 watt transformer. It has two 2 horsepower drives in it. So once you've added all your components, you can see here it actually shows you the dissipations estimated for those components right here. Once you're done with that, you can click on the results page. And like I said before, since we did not change our environment temperature, when I click on Filterfans, it's actually not going to give me a recommendation or solution for it. You can see here it's saying I need infinite amount of CFM, and that's because the ambient temperature is not lower than the enclosure temperature, so there's no way to use a passive cooling unit. You'll see the same thing with air-to-air heat exchanger here. Cannot actually provide a solution because an air-to-air needs the ambient to be lower than the enclosure temperature. So to fix that, we're going to go back to environment. This is going into a climate-controlled factory, so the temperature is actually between 65 and 75 degrees Fahrenheit. Once you've done that, you can actually come back to results, and you'll see here that it'll actually choose a Filterfan solution. So when you're on a page with a solution, you can actually click this drop-down menu here, and you can choose from a different number of solutions that will meet the cooling requirements. Let's say we wanted to use PF 65,000 with a PFA 60,000. Select it there, and you'll see it actually tells you how over capacity it is. So this one actually stands at more than double the capacity needed. So it would be more than enough to cool the enclosure. When using passive units, it's okay to have a high number of overcapacity, since there's low risk of any condensation and there's no active component such as a compressor that you're going to overload. But if you're using an active component, such as if we go to cooling units here, it's not recommended to go over capacity by more than 80%, because then you're going to put strain on the compressor from overcycling, because it'll just turn on, turn off, because it will cool the enclosure so quickly. Okay. So I'm actually going to go through scenario 2. It's actually very similar to scenario 1. Same enclosure size, except this one's stainless steel, because it's going into an environment where they use pretty corrosive and harmful cleaning material. So we're actually going to click on NEMA 4/4X here in the environment. The dissipation is the same, and then when we come to results here, we're actually going to look at an air-to-air heat exchanger. See that it'll actually select the PKS 3134, which is a NEMA type 4/4X. And after you have selected a unit, you can come here to detailed results. It'll give you a breakdown of the calculations here. You can also download these results as a PDF, and you can store these in a file or send them to a customer if they need them. So it is recommended to actually restart the project before you start a new one. I am going to not restart it because I want to show you what happens when you don't. So we're actually going to go to scenario 3. It's a mild steel. (84 by 120 by 24). It's in a not climate controlled factory where the temperature ranges between 80 and 100. It's NEMA type 12. And the dissipation for this one is 2 100 horsepower drives. You'll see here when we go to cooling units, it actually is selecting the 3041, which was the solution for the first scenario. It's telling you that you need 5 of these. So to fix this, if you actually click this drop-down menu, you can actually see the solutions here that will actually work for this enclosure. And I just noticed that in environment, I did not save my temperature. Just like I said, it should be 80 to 100. You'll see here, the recommended solution would be a DTS 3641, overcapacity at 30%. And again, you can always download your detailed results as a PDF and save them. So what you should do when you're starting a new project is come here to New. That'll actually refresh everything for you. And that way you won't get anything funky like where it saves the solution for an earlier scenario and tries to use it for that scenario. This one's actually very similar to scenario 3, but this one, they do have cooled water and the ambient is a little bit higher, so we're going to be looking at an air to water for it. And again, they have two 100 horsepower drives. So when you're on air to water, you actually do want to type in the water temperature that you have, because this will change the cooling capacity, the percentage of glycol, and then if they have the max flow requirement available, the 2.6, I always recommend using that, because that's how you're going to get the most capacity out of our air to waters. You'll see once you've done that. So that you can actually select your air to waters here. Oh, I forgot to add. I was wondering why it was selecting that unit. So I forgot to hit add the components, so it actually didn't have the full dissipation. You see here, it actually recommends the 31002 PWS to meet the cooling requirements of this scenario. The sizing software can also be used to calculate heating. It does that. It doesn't care about your dissipation when calculating heating, because it's more worried about keeping the cabinet at that minimum temperature even when your components aren't running, so that they can start up in that minimum temperature range. So we'll use the earlier scenario size enclosure. We're going to say we need to keep our minimum above 55 degrees Fahrenheit. It's mild steel. 230. But here we're going to say this is going outdoor, and that the min temperature actually gets down to 0 degrees Fahrenheit. And the max temperature is 90 degrees Fahrenheit. If you haven't filled out all the required information on a page, you actually can't go to different tabs as well. So it actually will stop you from leaving the enclosure page without filling out the enclosure size information. So, like I said, this is similar to scenario 1, where we had two 2-horsepower drives. One 4,000 watt power supply, and one 3,000 watt transformer. And you'll see now when we go to the results page, and actually select a heating option, and that's because our ambient is so much lower than the minimum temperature of the enclosure. You'll see here that a single PFH-T650 will be able to meet the heating requirement needed. That's how to use the PSS software. If you have any questions, feel free to email me or any of the other applications engineers here at Pfannenberg at sales@pfannenbergusa.com.